Hi there. We want to deal with topic 6, which has to do with ionic and molecular compounds. And so to understand ionic compounds, we need to figure out what might happen sometimes to atoms. Here's a sodium atom, and what happens is sometimes atoms might have an unequal number of electrons. So if they don't balance out between protons and electrons, we might get something called an ion. And so here's a chlorine atom. Its overall charge between the protons and the electrons is 0. However, sometimes things happen to the chlorine atom, radiation, heat, and they might form an ion which has an unbalance between the number of protons and electrons, giving it a charge. In the case of chlorine, a 1 negative charge. In the case of sodium, a 1 positive. So again, atoms versus ions. There are trends in the periodic table and certain behaviors that we need to be familiar with when it comes to what happens. For example, here's our periodic table down below. Metals tend to lose their electrons, which are negatively charged, to form positive cations. Cations are positive ions. So here are the alkali earths. They'll always form a 1 plus charge, so they give up 1 electron. Their atoms give up 1 electron to form 1 plus ions. The alkaline earth metals tend to form 2 plus ions, and the transition metals, it all varies. Aluminum and this column, which has no specific family, 3 plus. Now let's look at the nonmetals, which are over here. The noble gases never form ions, they're too stable. However, the halogens will form a 1 negative anion. So nonmetals, if they do form ions, form negatively charged anions. So nonmetals, we say, gain electrons to form negatively charged anions. Cations for metals, which are positively charged ions, anions for nonmetals. So here's what it looks like again. Metals lose. So these are the noble gases. Here's the halogens. This group or family has no specific name, but they would form 2 minus, alkaline earth, and the alkali. So ionic substances will form between ions. So we've talked about how atoms might form ions. And to do this in grade 9 science, this would be a metal ion joining up with a non-metal ion. There are other ways to make ionic substances, but in grade 9 science, we just need to worry about metal ions with non-metal ions. And what happens is the metal ion transfers its electron to the non-metal. So let's look at this. Ionic compounds consist of a cation and an anion. So let's take a simple example of how we would make NaCl, or it's called sodium chloride. Here's what the sodium ion would do. It would donate its electron over here to the chlorine ion, and the chlorine would accept it. So it's a transfer, we say, a transfer of electrons to create sodium chloride. Let's get into naming ionic compounds, because there's a special way we do this. So we would write the names of the cation first, that's the metal ion, and the name of the anion or the non-metal second. So metal ion, non-metal, always in an ionic compound. We change the non-metal to an ide. So this is sodium, the sodium ion. So we would call this sodium. And the nonmetal anion right here is called chlorine from the periodic table. Chlorine. But in step 2 we drop the ene and we add ide. And so this would be called sodium chloride. Let's see if we can, besides naming, if we can write them. Don't forget, when we see a metal with a non-metal, we know it has to be ionic, which means we're dealing with the ions. So let's write out the ions. Zinc from the periodic table of ions is a 2+. Sulfide is a 2-. In order for them to transfer electrons, the charges have to be balanced. This has to equal 0. And so if they do, we can just write ZnS. That would be solid because all ionic substances are solid at room temperature. Let's deal with calcium oxide. That's the ion calcium with the oxide ion. Are the charges equal to 0? Yeah. So we can join them together and it's CaO solid down below. Okay, let's keep going. Let's try some more. Let's see if we can name BaBr2. Again, first you have to ask yourself, is it ionic or molecular? If it's a metal and a non-metal, it's ionic, which means we're dealing with ions. That means this little number here is only there because we're balancing ions. So intermediate, it's barium. So we've got barium and we've got a bromine. So barium, bromine. Okay, that's the intermediate. Drop the ene and it's barium bromide. Let's see if we can go backwards. Cobalt fluoride. Let's write the two ions. The cobalt ion, CO, and I have to go to my periodic table of ions. Do I have one up here? Cobalt right there, CO2+. Always take the top one if you have two options for now. So CO2+. And fluorine is F1-. Okay, so now the charges don't balance out to 0. So that means I need 2 fluorine to get 2+ on this side, so it balances out. So I would write COF2 to balance out the charges. Let's do molecular compounds now. Molecular compounds are formed by the sharing, we call this covalent bonding, the sharing of electrons, not the loss or gain of electrons. And they only deal with nonmetals. These are binary here. These are called binary or diatomic, because they're atoms join together to create molecules of the same. So this is a molecule of hydrogen. It's not the element hydrogen. This is a molecule of oxygen. So some elements on the periodic table will form what we call diatomic molecular compounds. So let's see if once we know we have molecular compounds, then we need to consider this. These are called Greek prefixes. This helps us name molecular compounds. So step 1, you always figure out, is it a metal and a nonmetal and therefore ionic, or is it all nonmetals? If it's all nonmetals, then we use our Greek prefixes to help us name the substance. So let's practice. sulfur trioxide. How would we write that? Sulfur is S on the periodic table, and then oxide, that comes from oxygen, O, and tri stands for we have 3 of them. And so let's walk you through this. So we write SO, we write the number atoms, 1, but we never write 1 in chemistry, so we drop the 1, and then we write 3 there for tri, and we're done. Final formula. Let's try another one. So dichlorine, we write the symbols first, Cl and O. Then we write the numbers, 2 for di, hepta for 7. And there's our final formula. Next one. Oxygen difluoride, we write the O, we write the F. Okay, first we have to consider, is it all nonmetals? Yep. And therefore we know we're using Greek prefixes. It's all nonmetals, so we're using Greek prefixes here. Okay, so oxygen, we would write the 1, but then we'd get rid of it. And then fluorine or fluoride, that's F, and then we'd write the 2 there, and that's our final formula. So O, F, 1, drop the 1, you never write 1, 2, and there's our final formula. One more, dinitrogen tetraoxide. We write the symbols, N, O, we write the number of atoms, 2 for di, 4 for tetra, phosphorus pentachloride, write the elements, P, Cl, write the number of atoms, 1, drop the 1, penta is 5, and we're done. So I think you get the idea. Let's move ahead to a few other slides. We did this lab that I'm going to move to on properties of molecular and properties of ionic substances. And so I want to talk about that. Here it is. So we can use our knowledge of the fact that metals, and a metal ion and a non-metal ion indicate ionic, and all non-metals indicate molecular. So potassium is a metal. So that this is actually a complex polyatomic. So in grade 9 we don't have to know that, but this would be ionic. These are all non-metals, so this is molecular. Metal, non-metal, ionic, metal, and then complex. Don't have to know that. All non-metals, so this is molecular. All non-metals, molecular, metal, non-metal, ionic. This is one of those diatomics, so it's molecular, or not diatomic. Yeah, diatomic molecules, sorry. And when we did all these tests, what did we find out? Ionic substances form from metallic and non-metallic elements, of course, with their ions. They form ions in solution, they conduct electricity, and they're all solid at room temperature. And further to that, it's the transfer of electrons, okay, not sharing.